Hello class, I want to talk to you today in this tutorial about a one-way t-test. Okay? So let's get started. A one-way t-test is very similar to our z-test, our one-way z-test. If you remember, when we calculate z, x bar minus mu, which can be either our population average or a hypothesized population average, and we divide that by sigma over the square root of n, the sample size that we use, the samples that we use to get our sample average. But we generally don't know what that guy is. We generally don't know what sigma is. Okay, so what we need to do is we use the z. All right, so for the the t, so we have to calculate t. So t is very similar. X bar minus mu all three of these are very similar, except instead of the population standard deviation, we use sample standard deviation. So let's do an example. All right. In class we talked, in the first class we talked about M&Ms and red M&Ms. Okay? Let's say that M&Ms has said that the average number of red M&Ms is 16. And you're not buying that because you say, well, I don't usually get that many. So you want to test it. So you buy some individual bags of M&Ms. And then what you find is that take 16. You find the average to be 14. It's not a bad test. You get to eat some candy. And you know that you calculate your standard deviation, and we calculate it to be 2. All right, now we have all this information here, and let's set up our hypothesis test. Okay? So our hypothesis test would be, okay, so our null hypothesis is that mu is equal to 16. That's what M&M says. There's no reason not to believe it until we prove it otherwise. All right? Our alternate hypothesis would be, let's say, I think it's less. So you're saying, I think it's less. So let's say that it is less than 16. All right? So let's go ahead and calculate that. All right. So we know we have to do two things. First, we have to calculate t. And then second, we have to look up the t-value in the t-table, because we're going to compare what we calculate to the value in the back of the book. All right, so let's get started. For the first part, t is equal to x bar minus mu over s square root of n. All right? And we have our data, so we know that our average is 14. Our, let's call this mu 0, mu naught, is 16. That's our hypothesized mean. And we know S is 2, and our sample size is 16. Right? So we have minus 2 up here, divided by 2 over 4, which is going to yield us minus 4. Okay, so we have the first part done. All right, so let's put that here. So 1, we know that t is equal to minus 4. All right, now we have to look up the t value in the back of the book. All right, so we know t is equal to, when we look up the value, it's t alpha and this little the degrees of freedom right there, where the degrees of freedom is equal to n minus 1, and n is a sample size. So in our case, we are going to use alpha, our significance there, of 0.05. So then we write it as 0.05. The reason why we're doing it as 0.05, this is a one-tailed test because we're looking at it as less than. We're not looking at a two-tailed test here. And we know that degrees of freedom here is 16 minus 1. So we would look up 0.05 for significance and our degrees of freedom of 15. So that t value is 1.753. All right? And in this case, because we're going on the left side, we're going to, that will be a negative value, okay? Okay. And the way we look at this is to compare, do we accept, so now we get to the hypothesis testing. Are we going to accept or reject this right here? So how do we test that? Okay. What we're going to do here is we have to look at this distribution here, which is for alpha is 0.05 and our degrees of freedom is 15, okay? We know that minus 1.753 is here. So this is 95%, right? And anything up right here is going to be 5%. Okay. Anything that happens in here, we know that's most likely random. Any value that that ends up beyond minus 1.753 is not likely due to chance. Okay, so we know that minus 4 is way out here. Okay, so what does that mean? So we know that our t calculated is less than our t for 0.05 and 15, right? And in this case, what that means is that we would reject HO, okay? So we reject the null hypothesis, reject that mu is equal to 16, okay? We know, and then what that means is that our alternate hypothesis, H1, which says that mu is less than 16, is correct. And that's how you do a one-way t-test, and it's also a one-tailed, because we're doing it either greater than or less than. Okay, thanks.